Okay, so this H parameters are represented by the two equations what I shown you now, and they can be easily these two equations can be easily obtained. For the first equation, you have to apply Kirchhoff's voltage law at the input side. For second equation, you have to apply Kirchhoff's current law at this node. So these two equations can also be got by applying KVL at the input side and KCL at the output side. That is what is given here. The input side, you will have an voltage source, which is a dependent voltage source. Usually, voltage source will constant value, right? But here you see this voltage depends on V2. So it is a dependent voltage source. Usually current source will have a constant current, but this current source has a current dependent on I1. So it is a dependent current source. So input side I have a dependent voltage source, output side I have a dependent current source. So these are the important things you should remember when you draw the H parameter model of BJT. The H parameters are very common practice for manufacturers to label a transistor, and depending on the common base or common emitter or common collector, we'll be suffixing it with E, B, and C. E is for common emitter, B is for common base, and C is for common collector. So see here, it is general, it is HI, but when you have common emitter, it becomes HIE. In general, it is HO. When it is for common emitter, it becomes HOE. In general, it is HR. When it is for common emitter, it becomes HRE. In general, it is HF. When it is common emitter, it becomes HFE. So whatever configuration you are going to use, you'll be suffixing that alphabet along with these H parameters. So see the expression for see the explanation for HIE. HIE is input impedance. Short circuit input impedance. HOE output admittance. Open circuit output admittance. HRE reverse voltage gain. Reverse means the voltage gain nale output by input. Reverse voltage gain means it is the input by output. Forward current gain. Forward current gain is output by input. HI and HF you will be having short circuit. HO and HR you will be having open circuit. You have to understand that clearly. Okay, so these are the notations we'll be using it hereafter. Hereafter, we'll not be using H1122, we'll be using only HIE. So from HIE means you should understand two things. One, it is common emitter configuration. Second thing, I'm referring to the input impedance of the amplifier. When I write HOC, it means that it is common collector configuration and I'm going to measure the output admittance. When I write HRB, it is common base and I'm going to find the reverse voltage gain. When I write HFC, it is common collector and I'm going to find the forward current gain. So these H parameters will give you a lot of information about what parameter you are going to find and what configuration the transistor is working. Is that clear? So from H parameters, you can derive a lot of information.